Australia spent tens of millions of years alone, while the rest of the world filled with lions, wolves, bears, and big cats. This continent drifted in isolation, answering the same evolutionary questions with entirely different animals. Given enough time, it began producing predators and giants found nowhere else on Earth. A hunter more closely related to a wombat and a koala than to any cat evolved the strongest bite ever measured in a mammal. A giant lizard nearly 7 meters long, which is about 23 feet, may have become the largest venomous animal in the history of life. Even crocodiles left the rivers behind. One species evolved long legs and hunted by running across open country. The herbivores were no less extraordinary. Kangaroos heavier than a horse crossed the landscape beside enormous wombats weighing several tons. Giant flightless birds wandered a continent that looked very different from the Australia we know today. And somewhere among them, predators were always waiting. No other continent assembled a world quite like this. Not Africa, not the Ice Age plains of Europe, not the ancient Americas. Australia followed its own path for millions of years, creating an ecosystem so unusual that scientists are still debating why it disappeared. In this journey, we travel back to a lost Australia and meet the remarkable animals that turned it into one of the most dangerous places the world has ever known. But before we do, let me know in the comments, are you listening to this to fall asleep, or you're here only for the knowledge? Settle in and let's begin. A continent can change the course of evolution by doing almost nothing at all. Once Australia completed its separation from Antarctica around 50 million years ago, it began a long passage across the southern hemisphere, with very few opportunities for outside arrivals. That isolation lasted until the Indo-Australian plate finally approached Asia roughly 5.3 million years ago. During those immense stretches of time, the living world on Australia unfolded along its own path, shaped by circumstances that no other continent shared. Across Africa, Europe, Asia, and the Americas, placental mammals were expanding into new environments. Predators refined their hunting strategies through continual competition, while grazing animals responded with stronger defenses, greater speed, and increasingly specialized bodies. Australia remained apart from those exchanges. Lions never entered its grasslands. Wolves never pursued prey across its plains. Elephants never browsed its forests. Entire branches of mammalian evolution developed elsewhere, leaving Australia to build an ecological community from the lineages already present when the separation became complete. Those surviving lineages belonged largely to marsupials, animals whose young completed much of their development inside a pouch after a comparatively brief pregnancy. Freed from competition with many placental mammals, they diversified into forms that occupied almost every major ecological role. Some became swift grazers, others climbed through forests. A few eventually transformed into formidable hunters. Their ancestry remained unmistakably marsupial, even as their bodies began resembling animals found on distant continents. This pattern illustrates one of evolution's most elegant ideas, convergent evolution. The concept is surprisingly straightforward. When unrelated groups experience similar environmental challenges across long periods, natural selection can guide them toward comparable body shapes or lifestyles. The resemblance develops independently instead of passing through shared ancestry. A streamlined swimmer, an efficient runner, or a powerful predator often arrives at familiar solutions because the physical demands remain much the same wherever life attempts to solve them. Australia became one of the clearest demonstrations of this principle, producing creatures that echoed distant relatives while following entirely separate evolutionary histories. The land itself refused to remain constant. Throughout the Pleistocene, changing climates repeatedly transformed the continent. Dry intervals expanded open country, while wetter periods encouraged forests and broad woodlands to spread once more. Sea levels also rose and fell as global ice sheets advanced and retreated. At lower sea levels, land bridges connected Australia with Tasmania and New Guinea, allowing animals to move between regions before rising seas separated them again. Every shift altered habitats, food supplies, migration routes, and opportunities for survival. Life adapted through persistence instead of stability. Species that endured these repeating environmental changes passed along traits suited to flexibility as much as strength. Generation after generation encountered new combinations of drought, rainfall, expanding grasslands, and returning forests. Over immense spans of time, those pressures shaped an ecosystem unlike any other on Earth, one assembled from different evolutionary foundations while reaching many of the same ecological destinations. By the height of the Pleistocene, this long experiment had produced some of its grandest inhabitants. When European scientists uncovered enormous fossil bones during the 19th century, many struggled to believe they belonged to Australia at all. The skeletons seemed more suited to elephants or rhinoceroses from distant continents than to a land already famous for kangaroos and wombats. The fossils revealed something entirely different, a giant marsupial world patiently assembled through millions of years of uninterrupted isolation. The first impression of Diprotodon comes from its scale. Standing around 1.8 meters at the shoulder, which is about 5.9 feet, stretching more than 4 meters from nose to tail, that is nearly 13 feet, and weighing as much as 3,500 kilograms. It weighed about as much as a white rhinoceros. Yet this giant began life in the familiar marsupial way, entering the world as a tiny joey before continuing its earliest development inside its mother's pouch. The contrast between its delicate beginning and its immense adult form remains one of Australia's most striking evolutionary stories. When fossil remains emerged from Wellington Caves in New South Wales during 1830, many European naturalists struggled to interpret what lay before them. The bones seemed too large and too unfamiliar to belong to any known Australian animal. Comparisons were drawn with rhinoceroses, elephants, hippopotamuses, and even dugongs. Few imagined that an isolated continent had produced its own lineage of giant herbivores, entirely separate from the great mammals that shaped other parts of the world. The discovery gradually expanded scientific understanding of Australia's remarkable evolutionary history. Its appearance may have carried another unexpected feature. The position of the nasal bones has led several researchers to suggest that Diprotodon possessed a short, flexible trunk. Such a structure remains uncertain because soft tissues rarely survive fossilization, yet the underlying skull provides intriguing clues. If present, the trunk would have helped gather branches, leaves, and other vegetation, while giving the animal a profile faintly reminiscent of an elephant. Similar needs had guided unrelated creatures toward comparable solutions, another elegant expression of convergent evolution unfolding across distant continents. Feeding an animal of this magnitude demanded extraordinary efficiency. The jaws generated more than 11,000 newtons of force at the last molar, allowing thick branches and coarse vegetation to be crushed with steady power. Broad grinding teeth processed enormous quantities of woody plants every day. Hundreds of kilograms of food passed through its digestive system during a typical day, supporting muscles, bones, and organs on a body unlike any marsupial before or since. Evidence preserved across Australia suggests Diprotodon also undertook seasonal migrations, making it the only known marsupial to display this behavior. Large groups, often composed mainly of females and younger animals, crossed changing landscapes in search of dependable food and fresh water. Their walking pace averaged about 6 kilometers each hour, which is about 3.7 miles each hour, carrying these immense herbivores across forests, grasslands, and open country as conditions shifted with the seasons. Such journeys echoed migrations seen elsewhere in the world, though the travelers themselves belonged to a lineage found nowhere beyond Australia. Its presence lingered beyond the fossil record. Some scholars have proposed that memories of Diprotodon survived within traditions surrounding the bunyip, a powerful creature associated with water holes and Aboriginal storytelling. Whether the connection proves exact or symbolic, the possibility reflects how memorable an animal of such proportions would have been to the people who shared the landscape with it. One place preserves that relationship between life and hardship with unusual clarity. At Lake Callabona in South Australia, hundreds of Diprotodon skeletons remained where drought drove them into deep mud as they searched for water. Trapped together, they formed one of the richest fossil deposits on the continent, preserving a gathering of giants whose final journey became part of Australia's enduring geological memory. Among the many names preserved in the fossil record, few carry such an immediate sense of purpose as Thylacoleo carnifex. The first word comes from Greek and means pouched lion. The second comes from Latin and means butcher. When paleontologist Richard Owen introduced the animal to science in 1859, he possessed only incomplete remains, yet even those fragments convinced him he was examining one of the fiercest predators ever known. Later discoveries would reveal that his instinct had been remarkably close to the truth. Measured by body size alone, Thylacoleo seemed modest beside many of the herbivores that shared its homeland. Adults generally weighed between 90 and 130 kilograms, comparable to a modern lioness or a jaguar. Despite that moderate size, its bite delivered extraordinary power. A specimen weighing 101 kilograms produced a bite comparable to that of an African lion weighing around 250 kilograms. Calculations of bite force quotient place it near 194, among the highest values ever estimated for any mammal, living or extinct. Its appearance encouraged comparisons with cats, though the resemblance concealed a completely different ancestry. Thylacoleo belonged within the marsupial lineage, sharing closer relationships with wombats and koalas than with lions, leopards, or jaguars. Similar environmental demands gradually shaped unrelated animals toward comparable outlines, creating another striking example of convergent evolution. Familiar proportions emerged from an entirely separate branch of mammalian history, producing a hunter that echoed the silhouette of a feline while remaining biologically distinct. Its skull departed even further from the cat design. Large canine teeth, the hallmark of many mammalian predators, were reduced or almost absent. Instead, enlarged front incisors and an enormous blade-shaped third premolar formed the principal cutting equipment. That premolar ranks as the longest shearing tooth known among predators within its broader family, functioning like an efficient slicing edge capable of processing flesh with exceptional precision. Every feature suggests specialization refined through countless generations of successful hunting. Another unusual adaptation appeared in the forelimbs. An enlarged thumb carried a retractable claw protected within a sheath, closely resembling the concealed claws of modern cats, despite arising through an independent evolutionary pathway. Researchers have proposed that this powerful claw helped open the bodies of captured prey, complementing the remarkable jaws instead of merely assisting them. No other known predator combined these anatomical features in quite the same arrangement, giving Thylacoleo a distinctive place among mammalian carnivores. The rest of its skeleton hints at surprising versatility. Specialized tailbones, called chevrons, allowed the animal to brace itself while standing upright on its hind legs. This posture freed both forelimbs for grasping and powerful strikes. Robust shoulders, flexible joints, and retractable claws also indicate excellent climbing ability. Trees likely served as useful pathways and secure resting places, while elevated branches may have protected valuable carcasses from scavengers, much as leopards do across parts of Africa today. For roughly 2 million years, beginning during the late Pliocene and continuing until about 40,000 years ago, Thylacoleo held the role of Australia's dominant mammalian predator. Few carnivorous lineages anywhere have maintained such a commanding ecological position for so long. Each newly discovered skeleton continues to deepen that portrait, revealing an animal assembled through millions of years of refinement into one of the most specialized hunters the mammalian world has ever produced. Predators often reveal themselves through familiar patterns. A cat seizes with its forelimbs, then delivers the fatal bite. A wolf relies on endurance and repeated attacks. Thylacoleo followed neither path. Every major feature of its skeleton points toward a hunting strategy that reversed the sequence seen in living cats. Its extraordinary jaws appear to have restrained struggling prey first, leaving the powerful forelimbs free to perform the decisive work. The mouth became the anchor, while the claws became the principal weapons. This interpretation comes from the way its anatomy fits together. The enlarged incisors and immense slicing premolar could grip with tremendous force, locking onto flesh while resisting violent movement. At the same time, the forelimbs possessed exceptional strength, reinforced joints, and the enlarged retractable thumb claw already seen in the fossil skeleton. Once prey had been secured, those limbs could slash with precision across vulnerable parts of the body. No living mammalian predator combines these features in quite this arrangement, making Thylacoleo one of the most mechanically unusual hunters yet reconstructed. Evidence supporting this picture survives in the skeletons of its prey. Several fossil bones display deep grooves and sharply defined cuts consistent with powerful slicing teeth. These marks remain preserved for tens of thousands of years, recording encounters that vanished long before human history began. Each scar preserved in fossil bone serves as another clue, allowing paleontologists to compare injuries with the shape and function of Thylacoleo's remarkable dentition. The bones themselves became part of the record, preserving details long after flesh and muscle had disappeared. Its hunting range extended well beyond the ground. Strong shoulders, flexible limbs, and curved claws indicate an accomplished climber capable of moving through trees with confidence. Elevated branches offered excellent positions for concealment before a rapid descent onto passing animals below. Climbing also provided practical advantages after a successful hunt. Carcasses placed above the ground would have remained harder for scavengers to reach, preserving valuable food over longer periods. Such behavior closely parallels strategies used by modern leopards, although the two predators arrived at those solutions through entirely separate evolutionary histories. Life within caves adds another dimension to its behavior. Fossil evidence indicates that Thylacoleo likely sheltered and raised its young inside protected cave systems. These enclosed spaces offered stable conditions for vulnerable joeys, while also serving as secure resting places for adults. Modern research published in the journal Scientific Reports has strengthened the interpretation that this predator combined climbing ability with regular use of caves, revealing a level of behavioral flexibility still being explored through new discoveries. The prey list reflects equal versatility. Giant kangaroos, large wallabies, and even enormous herbivores such as Diprotodon outweighed Thylacoleo by substantial margins. Size alone offered limited protection against a hunter capable of delivering overwhelming force during a brief encounter. Success depended on surprise, powerful restraint, and specialized anatomy working together in a coordinated sequence refined across countless generations. The influence of such a predator extended far beyond the individuals it captured. Every browsing herd, every grazing marsupial, and every animal moving between woodland and open country carried the constant pressure of adapting to its presence. Vigilance, movement, and habitat choice all unfolded within an ecological landscape shaped by one remarkably specialized hunter whose methods remain unlike those of any other mammalian carnivore known to science. Few fossil animals challenge the imagination as completely as Varanus priscus, more widely known as Megalania. It belonged to the monitor lizard family, yet every known relative alive today seems diminished beside it. Current studies suggest that many individuals reached around 5.5 meters in total length, which is about 18 feet, while the largest estimates extend toward 7 meters, that is nearly 23 feet. Even the more conservative figures place it among the greatest terrestrial reptiles ever to roam the land. Modern comparison helps place its dimensions into perspective. The largest living Komodo dragons grow to roughly 3 meters, that is nearly 10 feet, and usually weigh around 90 kilograms. Megalania exceeded twice that length and may have approached 600 kilograms, carrying about the same mass as a full-grown horse. Such proportions transformed an already formidable body plan into something entirely different, a giant reptile capable of moving across Australian plains with steady confidence while occupying the highest tier of the reptilian food web. Its ancestry provides another remarkable clue. Megalania belong to the same broader family as living monitor lizards, animals equipped with venom-producing glands inside the mouth. Fossils cannot preserve those delicate tissues, leaving direct confirmation beyond reach. Even so, evolutionary relationships strongly suggest that Megalania inherited the same biological equipment. Among living monitors, venom contributes to successful hunting through a combination of mechanical injury and chemical effects, making a similar strategy highly plausible for their giant relative. Researchers propose that its venom contained compounds capable of lowering blood pressure and encouraging severe internal bleeding. Such toxins, often described as hemotoxins, gradually weakened injured prey after a bite. Instead of relying on immediate force alone, the lizard could have followed an increasingly exhausted animal until strength failed completely. Teeth opened the wound, while venom steadily magnified its effects across time. The combination created an efficient hunting system without demanding prolonged physical struggle. If this interpretation proves correct, Megalania occupies an extraordinary place in natural history. No venomous snake, fish, or other known creature approached its overall body size. The title of largest venomous animal would belong to a reptile that outweighed many hoofed mammals while carrying chemical weapons usually associated with far smaller hunters. Evolution assembled an uncommon blend of immense strength and physiological precision within a single predator. The skull, jaws, and teeth further support its role as an accomplished carnivore. Curved teeth gripped flesh securely before tearing it apart with repeated movements of the head and neck. Fossils discovered across central and eastern Australia, extending as far south as Narracorty Caves in South Australia, reveal a distribution spanning an enormous portion of the continent. It likely hunted whenever suitable opportunities appeared, while also feeding upon carcasses, allowing little edible material to remain unused within its territory. The youngest known remains of these giant monitor lizards date to around 50,000 years ago, placing them close to the arrival of the first people in Australia. Those early travelers entered landscapes where Megalania had already ruled for well over 1 million years. Each side represented something entirely unfamiliar to the other. The giant lizard had never encountered upright human hunters, while the newcomers possessed no inherited experience of a reptile approaching the size of a small truck. Their brief coexistence marked one of the most remarkable meetings in the long history of life on the continent. Crocodiles are usually imagined at the edge of water, with only their eyes and nostrils breaking the surface while they wait for an unsuspecting animal to approach. Across much of the world, that image remains accurate. Rivers, lakes, and swamps shaped the lives of crocodilians for millions of years, and their bodies became exquisitely adapted for ambush at the water's edge. Australia, however, preserved a lineage that gradually stepped away from that familiar existence and carried an ancient design into an entirely different setting. That animal belonged to the genus Quinkana, one of the Megalanian crocodilians that inhabited Australia from roughly 25 million years ago until about 20,000 years ago. Such longevity is remarkable in its own right. Entire groups of large predators elsewhere appeared and vanished within shorter spans, while Quinkana persisted through repeated environmental changes that reshaped forests, grasslands, and rainfall patterns across the continent. Its skeleton reveals a crocodilian that spent much of its time on land instead of floating in rivers. Longer limbs elevated the body well above the ground, allowing more efficient movement across open terrain than the sprawling posture of modern crocodiles. Rather than depending upon a sudden strike from water, Quinkana likely pursued mammals, birds, and reptiles across woodland and scrub, maintaining pressure until an opportunity for attack emerged. The familiar crocodile silhouette remained recognizable, although its behavior had shifted into a role almost unimaginable for living species. The teeth reveal how thoroughly that transition unfolded. Aquatic crocodiles possess narrow, conical teeth designed to grip struggling prey before dragging it beneath the surface, where drowning becomes the principal means of dispatch. Quinkana no longer relied upon deep water to finish a hunt. Its teeth developed sharp cutting edges capable of slicing flesh on dry ground. As hunting strategy changed, the skull and dentition changed alongside it, demonstrating how evolution reshaped an ancient body plan without abandoning its fundamental crocodilian heritage. Most estimates suggest adults reached between 5 and 6 meters in length, which is about 16 to 20 feet. At that size, Quinkana ranked among the largest terrestrial predators of prehistoric Australia. Fossil evidence indicates that cave entrances, woodland margins, and lightly forested habitats probably formed important parts of its hunting territory. These landscapes offered concealment while still allowing enough room for rapid pursuit whenever suitable prey appeared within reach. One fossil locality provides an extraordinary glimpse into the broader community surrounding this predator. At South Walker Creek in western Queensland, remains of Quinkana were uncovered alongside fossils representing 16 additional megafaunal species. Carnivores at the site included Thylacoleo, 2 giant monitor lizards including Megalania, and 3 separate crocodilian species. Such an assemblage demonstrates that Australia's predator community possessed remarkable diversity, with several enormous hunters occupying overlapping landscapes over long periods. Sharing territory did not necessarily mean sharing identical lifestyles. Differences in preferred habitats, prey selection, movement patterns, and hunting techniques reduced direct competition while allowing each predator to exploit its own opportunities. Woodland, grassland, rocky country, and water margins each supported distinctive strategies, weaving together an ecosystem of exceptional complexity unlike any surviving today. Within that intricate landscape, Quinkana stands as one of evolution's most surprising experiments. A crocodilian lineage abandoned the rivers that had defined its ancestors for countless generations and mastered life across the land, leaving behind fossils that still reshape our understanding of how flexible even the oldest predator designs could become when isolated on a continent unlike any other. Water shapes every landscape, although its influence becomes most visible when it grows scarce. Across Pleistocene Australia, long dry intervals gradually concentrated life around a shrinking network of springs, billabongs, rivers, and permanent waterholes. Herbivores arrived to drink. Carnivores arrived because the herbivores had no alternative. Every journey across the continent eventually narrowed toward the same destinations, turning each remaining pool into a place where countless paths crossed within a small patch of ground. Among the hunters waiting there was Wonambi neracortensis, a broad-bodied, constricting snake that reached about 6 meters in length, which is about 19.7 feet. Unlike Australia's venomous snakes of today, Wonambi relied entirely on muscular strength. After seizing prey with hundreds of small, backward curving teeth, it wrapped powerful coils around the animal, tightening each time the victim exhaled. Blood circulation failed, breathing became impossible, and movement gradually ceased beneath relentless pressure instead of venom. Its proportions made it unlike most living pythons. The body measured roughly 1 foot across, which is about 0.3 meters, while the head spread almost as wide as the thick neck behind it. The broad skull resembled the shape of a sturdy shovel more than the narrow head of many modern snakes. Fossil evidence suggests prey commonly included animals up to the size of a wallaby, captured through sudden ambush beside waterholes or along rocky passages where escape routes became restricted. Wonambi also represented the final chapter of a much older family. It belonged to the Matsoid snakes, a lineage once distributed across the southern continents that had formed Gondwana. As millions of years passed, those relatives vanished from every other landmass. Australia remained their final refuge after roughly 55 million years ago, preserving one of the last survivors of an ancestry that stretched far deeper into Earth's history than most living snake groups. Another giant serpent appeared even earlier. Fossils from the Pliocene reveal the Bluff Downs giant python, classified within the genus Liosus, reaching approximately 10 meters in length, which is about 32.8 feet. Such dimensions approached the length of a modern passenger bus. Woodland bordering rivers provided suitable hunting grounds where mammals, birds, and reptiles moved between shelter and water. Coils of that size could overpower remarkably large animals through strength alone. Names sometimes preserve memories that bones alone cannot explain. Wonambi received its scientific name from an Aboriginal tradition describing the rainbow serpent, a powerful being associated with water holes and the shaping of the landscape. While mythology and paleontology speak through different languages, their meeting at the same places suggests that remarkable snakes occupied a lasting place within cultural memory long after living encounters had disappeared. Viewed together, these animals transformed every permanent source of water into a convergent zone, unlike almost anywhere else on Earth. A thirsty herd approaching open ground could have encountered Quinkana moving through woodland, Megalania waiting nearby, Wonambi concealed at the water's edge, while Thylacoleo watched from elevated cover. Each predator occupied a different position within the same landscape, reducing direct competition while exploiting the unavoidable movements of prey. The remarkable feature of this ecosystem was not merely the presence of giant hunters, but the way each specialized in a different method. Chases across open country, ambushes from vegetation, constriction beside water, and attacks launched from elevated positions formed overlapping layers of danger surrounding the continent's most essential resource. Water sustained every creature, yet the same necessity also brought predator and prey together with extraordinary regularity, allowing Australia's long evolutionary experiment to reach one of its most intricate expressions. A landscape can appear crowded with hunters while remaining remarkably stable across immense spans of time. At first glance, such a scene seems to challenge one of ecology's most familiar patterns. Large predators usually compete intensely for food and territory. Across much of the modern world, the largest carnivores reduce one another's numbers through conflict, exclusion, or competition for the same prey. Pleistocene Australia presents a striking exception, preserving evidence that several formidable predators occupied overlapping landscapes for millions of years without collapsing the system that sustained them. Fossils collected from many localities reveal repeated associations between giant reptiles, powerful marsupial hunters, and enormous herbivores. These discoveries did not represent isolated moments separated by great distances. Instead, they formed a recurring pattern, extending across broad regions and long intervals of geological time. The evidence indicates that Thylacoleo, Megalania, Quinkana, and giant constricting snakes shared many of the same environments, drank from the same shrinking water sources, and depended upon overlapping communities of prey while maintaining their presence generation after generation. Ecologists describe one important explanation as ecological partitioning. Species may occupy the same region while reducing direct competition by dividing resources in different ways. Thylacoleo appears to have favored woodland margins, elevated cover, and sudden ambushes directed toward medium and large marsupials. Megalania ranged across more open country as both predator and scavenger, its probable venom allowing wounded prey to weaken after escaping the first encounter. Quinkana hunted along woodland corridors and open ground with limbs suited for pursuing animals on land. Giant snakes remained near waterholes or rocky passages where concealment rewarded patience more than speed. Those differences reduced competition, although they never removed it completely. Fossil bones occasionally preserve tooth marks or feeding damage that cannot always be assigned with certainty to a single predator. Some carcasses may have passed from one hunter to another as scavengers arrived after the initial kill. At other moments, living predators almost certainly crossed paths. Rather than constant battles for dominance, they may have responded through avoidance, brief confrontations, or simple recognition that another dangerous hunter already occupied the immediate area. Abundant prey probably supported this arrangement. Herds of Diprotodon weighing as much as 3,500 kilograms, which is about 7,716 pounds, wandered across broad seasonal ranges. Giant kangaroos browsed alongside large wallabies and towering flightless birds. Such immense herbivore populations represented an enormous reserve of living energy. Predators could specialize without exhausting every available food source because the landscape continually produced fresh opportunities across changing habitats and shifting seasons. Even so, the system never stood in effortless balance. Every predator limited the movements of the others. Every herbivore adjusted feeding routes, migration timing, vigilance, and habitat choice in response to several threats operating simultaneously. Selection acted from multiple directions at once, favoring animals capable of recognizing different dangers instead of adapting to only one. Countless interactions unfolded each day, producing an ecological network whose complexity exceeded the influence of any single species. This perspective transforms the meaning of danger within the Australian landscape. A greater number of predators did not inevitably weaken the ecosystem. Their combined influence helped regulate herbivore populations, redistributed grazing pressure, encouraged movement across varied habitats, and reduced prolonged concentration at individual feeding grounds. Through those constant interactions, each lineage shaped the fortunes of the others, creating an intricate community that endured across extraordinary stretches of time, sustained by pressure, adaptation, and continual change. Once the hunters become familiar, the great herbivores begin to look different as well. Their bodies no longer seem oversized curiosities, shaped only by food and climate. Every limb, every eye, every stride reflects generations spent sharing the landscape with predators that attacked from trees, open plains, rocky passages, and shrinking water holes. Survival depended upon recognizing danger from several directions at once, and the animals that endured carried those pressures within their anatomy. Among the most remarkable was Procoptodon goliath, the giant short-faced kangaroo, the largest kangaroo known to have lived. Adults stood between 2 and 3 meters tall, which is about 6.6 to 9.8 feet, and weighed as much as 230 kilograms, which is about 507 pounds. Its face appeared unusually broad and shortened compared with living kangaroos, creating a profile unlike anything alive today. Viewed from a distance, it scarcely resembled the familiar grazers that now cross the Australian interior. One of its most striking characteristics was the position of its eyes. Facing more toward the front than those of many grazing mammals, they provided improved three-dimensional vision and more accurate judgment of distance. Predators often possess this arrangement because precise depth perception helps calculate the final movement before an attack. In Procoptodon, the same visual advantage likely improved the ability to detect approaching threats, judge escape routes through scattered vegetation, and recognize movement at different heights before committing to a leap across open ground. Its feet reveal another remarkable adaptation. Unlike modern kangaroos, which retain several functional toes, Procoptodon balanced primarily upon a single enlarged toe. The arrangement resembles the evolutionary pathway followed by horses, where concentrating weight onto one strong digit improves efficiency across firm ground. On Australia's broad plains, such specialization probably allowed a heavy animal to travel greater distances with less energy while maintaining speed when pursued across open country by terrestrial predators. Birds also reached extraordinary proportions. Genyornis newtoni stood more than 2 meters tall, which is about 6.6 feet, and weighed up to 350 kilograms, which is about 772 pounds. Despite its imposing appearance, this giant belonged to the same broader lineage as ducks and geese instead of emus or ostriches. Evolution had transformed a group, usually associated with wetlands, into towering flightless browsers that occupied ecological roles filled elsewhere by large grazing mammals. An even larger relative appeared earlier in Australia's history. Dromeronus stertoni approached 3 meters in height, which is about 9.8 feet, and weighed around 500 kilograms, which is about 1,102 pounds. It ranked among the heaviest birds ever known. Such immense size meant that any predator confronting a healthy adult risked meeting powerful legs capable of delivering devastating blows. These birds were prey within the ecosystem, although they also demanded caution from hunters selecting their targets. Evidence from archaeological sites adds another layer to their story. Charred fragments of Genyornis eggshell discovered beside human artifacts indicate that the eggs formed part of the diet of the first Australians. Each egg represented an exceptionally rich supply of nourishment, although collecting one almost certainly required approaching nesting grounds defended by birds of imposing stature and considerable strength. Taken together, these herbivores and giant birds completed a living community shaped through millions of years of shared evolution. Every improvement in speed encouraged greater hunting skill. Every advance in ambush selected for sharper perception. Every defensive adaptation inspired another response somewhere else within the same web of life. The continent had become an intricate conversation between hunter and prey, written across bodies as much as across the landscape itself. Across the northern horizon, the continent waited beyond stretches of open sea. Reaching it demanded planning, cooperation, and deliberate navigation from island to island across waters that could not be crossed by chance alone. The people who arrived carried carefully made tools, shared knowledge, and the ability to organize journeys extending beyond the edge of familiar coastlines. They entered a land unlike any their ancestors had known, bringing minds already capable of remarkable adaptation, even as the country itself offered challenges without precedent. Current archaeological evidence shows that Australia has been inhabited for at least 45,000 years, while several lines of research suggest the first arrivals may have reached the continent as early as 65,000 years ago. Whatever the precise date, these travelers were fully modern humans who intentionally crossed from Southeast Asia. They were explorers rather than castaways, prepared to settle unfamiliar country. Even so, mastery of fire, stone, and cooperation did not immediately place them above every other living creature. They had entered an ecosystem that had evolved for millions of years without human hunters. The forests, plains, rocky valleys, and shrinking water sources already belonged to established predators. Thylacoleo still occupied woodland margins and climbing routes. Megalania continued its patrols across open country. Quinkana remained a powerful presence wherever land hunters pursued prey. Wonambi still waited beside favored approaches to precious water. None of these animals had inherited an instinct that identified an upright primate carrying stone tools as something fundamentally different from any other unfamiliar animal crossing its territory. Encounters unfolded without generations of learned caution shaping either side. The newcomers possessed no inherited stories describing these remarkable creatures. No elder could recount the habits of a giant marsupial predator descended from distant relatives of wombats and koalas. No tradition warned children about a monitor lizard growing around 5.5 meters long, which is about 18 feet, or perhaps even larger in exceptional individuals. Knowledge had to be built through direct experience, observation, and memory. Every successful journey added another lesson. Every dangerous meeting expanded a growing understanding of the continent. One landscape preserves this long relationship with unusual clarity. The Willandra Lakes contain evidence for continual Aboriginal occupation beginning around 50,000 years ago, while also preserving fossils of Australia's great megafauna. The archaeological record indicates that people and these giant animals shared the same environment for at least 17,000 years. That span exceeds countless human lifetimes, allowing practical knowledge, seasonal movements, and cultural traditions to mature alongside creatures that had dominated the landscape long before people arrived. Among those encounters, Megalania stands apart. For more than 1 million years, this immense monitor lizard had occupied its ecological role across broad regions of Australia. Early human communities may have watched its movements, interpreted its tracks, and learned where caution was most necessary. At the same time, the reptile confronted an unfamiliar primate capable of coordinated action, patient observation, and increasingly sophisticated hunting strategies. Each species represented something entirely new to the other, sharing the same country without any evolutionary history together. For thousands of years, this remarkable coexistence endured. Human communities spread across the continent, while the great marsupials, giant reptiles, immense birds, and enormous snakes continued to occupy their established places within the living network. The fossil record preserves this prolonged overlap before revealing a transformation that unfolded within a comparatively brief geological interval. One by one, the largest members of this extraordinary world vanished, leaving behind traces that continue to shape one of the most enduring scientific debates surrounding Australia's distant past. The change did not arrive as a single dramatic moment preserved in one layer of rock. It unfolded across the continent until the familiar giants became fewer with each passing age. Fossil deposits that once recorded an extraordinary diversity of massive animals gradually shifted toward a different picture. The great herds, towering birds, formidable reptiles, and enormous marsupial predators that had shaped Australia for millions of years slipped from the record, one after another, leaving an absence that remains one of the most remarkable biological transformations ever documented. More than 60 known faunal species disappeared from Australia during the Middle and Late Pleistocene. Most belong to the largest members of the continent's unique communities, including giant marsupials, immense flightless birds, and formidable reptiles. The losses were not scattered randomly across unrelated groups. They repeatedly affected animals, sharing one characteristic above all others: exceptional body size. Across landscapes that had supported these creatures through countless environmental fluctuations, the largest inhabitants declined until they were gone. The pattern becomes even more striking when body mass is examined. More than 85% of Australia's mammals, birds, and reptiles weighing over 100 pounds, which is about 45 kilograms, disappeared after the arrival of the first people. An even sharper boundary appears among the heaviest land animals. Every known Australian terrestrial species, exceeding 100 kilograms, which is about 220 pounds, became extinct. Species below that threshold often survived. Those above it almost never did. Such precision resembles a signal repeated across an entire continent instead of a collection of unrelated events. The fossil record adds another layer to this remarkable sequence. Many species had already become uncommon before the final disappearance of the most celebrated giants. Diprotodon, Thylacoleo, and the giant short-faced kangaroos remained present at sites dating to roughly 47,000 and 46,000 years ago. Their persistence suggests that the largest animals endured longer than many smaller companions. If environmental deterioration alone had driven the process, researchers might expect more fragile species to vanish first and the biggest survivors to disappear much earlier. The evidence instead reveals a prolonged endurance, followed by an unusually concentrated conclusion. The pace of that conclusion has attracted sustained scientific attention. Current evidence indicates that megafaunal extinction began within about 2,000 years after humans colonized Australia and was largely complete within another 2,000 years. Measured against ordinary geological time, this interval is astonishingly brief. Ecosystems assembled over tens of millions of years were transformed within a span shorter than many recorded chapters of human civilization. The contrast between the immense age of the ecological community and the rapidity of its disappearance continues to shape every discussion surrounding this period. Equally remarkable is the geographic consistency. From arid interior plains to woodland, river systems, and coastal regions, the same broad pattern appears across Australia. Different climates, different habitats, and different local histories all converge upon a similar outcome. Large-bodied animals vanished with extraordinary regularity, while many smaller species continued into the present. The continent speaks through repeated evidence rather than isolated discoveries, preserving a biological signature that has challenged interpretation for decades. From this enduring pattern emerged two principal explanations, each seeking to account for one of natural history's most profound transformations, and each supported by evidence that continues to invite careful examination. A population can disappear without dramatic battles or landscapes covered with bones. Sometimes, the decisive force is almost impossible to notice while it is unfolding. One generation follows another, births become slightly fewer than deaths, and the difference appears too small to matter. Across centuries, however, those tiny imbalances accumulate until an animal that once seemed permanent gradually fades from the living world. Extinction often advances through arithmetic before it ever becomes visible in the fossil record. Research published during 2017 examined the timing of megafaunal disappearance in southwest Australia and concluded that extinction occurred between about 45,000 and 43,100 years ago. The investigators found no evidence that this interval corresponded with major changes in climate, vegetation, or the amount of plant material available across the region. Nor did records of widespread burning indicate an environmental transformation large enough to explain the sudden loss of giant animals. Their findings remained consistent with a growing human influence spreading through the landscape during the same period. The proposed mechanism differs greatly from the image of relentless hunting parties pursuing every giant creature they encountered. A study published during 2006 demonstrated that even an extremely small increase in mortality could eventually eliminate large animals with slow reproductive cycles. The mathematical model suggested that killing only one juvenile animal per person during each decade might have been sufficient. Such losses would scarcely be noticed within a single lifetime. Across many generations and over an entire continent, however, the numbers steadily moved in only one direction. The biology of large animals made this process especially unforgiving. Species with substantial body mass generally require long pregnancies, produce few offspring, and invest years raising young before those juveniles can reproduce. Modern elephants provide a familiar comparison, commonly giving birth to a single calf every 4 or 5 years. Whenever deaths consistently exceed successful births by even a narrow margin, population recovery becomes increasingly difficult. Small annual deficits compound over centuries until decline becomes unavoidable, despite the continued presence of apparently healthy adults. Another possibility concerns behavior shaped through millions of years of evolution. Australia's great herbivores had never shared their world with a tool using primate capable of coordinated hunting. Their responses had evolved around predators that relied upon speed, concealment, venom, or powerful jaws. An upright human approaching across open ground represented something entirely unfamiliar. Caution learned through previous evolutionary experience may not have prepared these animals for a hunter capable of planning, persistence, and cooperation. A trait that had served them well for immense spans of time may suddenly have become a disadvantage. Additional evidence emerged from an unexpected source preserved within layers of sediment. Researchers measured the abundance of the dung fungus, called Sporormiella, whose spores provide a reliable indicator of large herbivore populations. For roughly 150,000 years, these spores remained abundant, reflecting thriving herds across the continent. Between about 45,000 and 43,100 years ago, the signal declined sharply. The spores recorded fewer large animals, depositing dung upon the landscape. Instead of documenting extinction through broken skeletons or stone weapons, the record traced the disappearance of grazing communities themselves. Even so, the discussion remained incomplete, because one influential line of direct evidence would later face a challenge that reshaped the entire debate. For nearly half a century, one fossil bone occupied an unusually influential place in the story of Australia's vanished giants. It was only a fragment, a fossilized tibia recovered from Mammoth Cave in southwestern Australia, yet it carried extraordinary weight within scientific discussion. A distinctive mark across its surface appeared to preserve the unmistakable signature of a stone tool. Since a study published during 1980, that single cut had often been presented as the strongest direct indication that the first Australians had butchered one of the continent's great megafaunal animals. The fossil belonged to a giant Sthenurine kangaroo, one of the remarkable short-faced kangaroos that shared Australia with humans for thousands of years. If the interpretation proved correct, the evidence would bridge an important gap between correlation and demonstration. Human arrival and megafaunal extinction already occurred within closely overlapping periods. A butchering mark would connect those events through direct physical evidence, transforming an attractive hypothesis into something much firmer. Because such fossils are exceptionally uncommon, this specimen acquired a status far beyond its modest size. That long-standing interpretation changed during October 2025. Professor Mike Archer, the paleontologist who had originally described the specimen decades earlier, publicly accepted that the original conclusion was mistaken. Re-examination showed that the mark had not been made while the animal was alive or immediately after death through butchery. Instead, the damage occurred after the bone had already entered the natural processes that affect buried remains. The celebrated cut no longer represented confirmed evidence of human hunting. This revision carried significance, extending well beyond a single fossil. For decades, the Mammoth Cave specimen had frequently been described as the strongest physical support for the idea that Australia's first peoples directly hunted megafauna. Once that interpretation was withdrawn, the discussion returned to a position of greater uncertainty. Human communities still overlapped with giant animals. Extinctions still followed human arrival within a comparatively brief geological interval. Those observations remained unchanged. What disappeared was the most frequently cited piece of direct evidence linking one event to the other. Importantly, The researchers did not conclude that humans never hunted Australia's megafauna. Such a claim would reach beyond the available evidence. Large animals may well have been hunted whenever opportunities arose. Stone tools, organized cooperation, and detailed environmental knowledge certainly made that possible. The revised conclusion instead emphasized a narrower point. Without unambiguous physical evidence showing direct hunting, responsibility cannot be assigned with complete confidence. The proposed mechanism remains plausible, yet it has not been conclusively demonstrated. The change illustrates an essential feature of science itself. Long accepted ideas remain open to revision whenever stronger evidence or improved analysis emerges. A conclusion repeated across decades does not become permanent through repetition alone. Every interpretation must continue to withstand renewed examination, especially when it influences understanding of events as consequential as a continent-wide extinction. Today, the broad pattern still invites explanation. The timing of human arrival, the disappearance of giant animals, and the distinctive size threshold all remain firmly established observations. The mechanism connecting them has become less certain than many once believed. Across Australia, an incomplete fossil record, uneven preservation, and roughly 50,000 years of geological change continue to conceal much of the evidence that might eventually resolve the question, leaving climate as the remaining major explanation requiring equally careful examination. Long after many of Australia's giant animals had already faded from the landscape, the climate continued its steady transformation. Peak glaciation arrived about 18,000 years ago, bringing increased dryness across much of the continent. Rivers contracted, lakes diminished, and productive habitats became more fragmented. These changes certainly reshaped ecosystems, yet they arrived after most of the largest marsupials, birds, and reptiles had already disappeared. The sequence itself presents the central difficulty. The harshest climatic conditions followed the principal wave of extinction instead of preceding it. This timing has remained one of the strongest challenges facing a purely climatic explanation. Throughout the Pleistocene, Australia experienced repeated swings between cooler, drier intervals and warmer, wetter landscapes. Forests expanded, then retreated. Grasslands spread across broad plains before yielding again to changing rainfall. Deserts advanced and later withdrew. Those cycles unfolded many times over hundreds of thousands of years, and the megafauna endured each transition. Their survival through repeated environmental shifts suggests that changing climate alone had rarely been enough to erase entire lineages that had already demonstrated remarkable resilience. Evidence from pollen, sediment cores, fossil deposits, and other environmental records strengthens that impression. Across many regions, researchers have found little indication of an exceptional climatic disruption during the narrow interval when the principal megafaunal collapse occurred. Vegetation continued changing as it always had, although without signs of an environmental catastrophe matching the sudden disappearance of so many large species. If climate served as the only driver, many scientists would expect the environmental record to display a correspondingly dramatic signal during precisely that period. Supporters of the climate hypothesis, nevertheless, present an important perspective. Some researchers argue that the decline of several large species may have begun well before humans reached Australia. According to this view, repeated climatic fluctuations gradually reduced populations across the late Middle Pleistocene and early Late Pleistocene. Habitats became increasingly patchy, breeding populations more isolated, and recovery from drought more difficult. By the time people arrived, Many species may already have existed in smaller numbers than they had during earlier ages, leaving them vulnerable to additional pressures that otherwise might have been absorbed. This possibility has encouraged many scientists to move beyond viewing the debate as a contest with only one correct answer. Climate and humans need not be mutually exclusive explanations. A drying continent could reduce food supplies, compress reliable water sources, and fragment once connected populations. Human communities, even without widespread hunting, introduced an influence unlike any previous force within Australia's ecosystems. Purposeful burning altered vegetation patterns, encouraged different plant communities, and changed the distribution of resources across broad areas. These modifications reshaped landscapes that countless generations of giant animals had previously navigated under different ecological conditions. Seen together, the evidence suggests a continent encountering overlapping pressures instead of a single catastrophic event. An ecosystem that had endured ice ages, prolonged droughts, and formidable predators possessed remarkable endurance within familiar boundaries. The arrival of a highly adaptable tool using species introduced forms of disturbance unlike those experienced during millions of years of earlier evolution. Whether direct hunting occurred often or only occasionally, the broader ecological consequences may have been sufficient to push already stressed populations beyond recovery. Climate established the conditions, people altered the system, and the combination appears more consistent with the available evidence than either explanation standing entirely alone. Memory does not always rest inside stone. Sometimes it travels through voices, carried across generations, until the landscape itself becomes part of the story. Australia preserves one of humanity's most extraordinary examples of that endurance. Long after the giant animals vanished from forests, plains, and wetlands, echoes of their presence continued within the Dreamtime traditions of Aboriginal Australians, whose cultural record extends farther into the past than any other living tradition known today. Among the figures that appear across many regions is the bunyip, a formidable creature associated with lakes, swamps, billabongs, and permanent water. Descriptions differ from one community to another, as expected across a continent shaped by many distinct languages and cultural traditions. Even so, some researchers have suggested that memories of Diprotodon may have contributed to these accounts. Diprotodon favored wetlands and freshwater habitats where large animals gathered to drink. A creature of such immense size, encountered beside still water, would have left an impression capable of surviving long after its final footprints disappeared beneath changing sediments. Another enduring presence appears in the rainbow serpent, one of the most significant beings within many Dreamtime traditions. The extinct snake Wonambi received its scientific name from this ancient figure because of striking similarities between the stories and the fossil animal itself. Wonambi measured about 6 meters, which is about 19.7 feet, and hunted by waiting near water before overpowering prey with muscular coils. Across numerous traditions, the rainbow serpent is likewise connected with water holes, rivers, life-giving springs, and immense power. Although these narratives carry profound spiritual meanings extending far beyond zoology, the shared association between enormous serpents and permanent water has encouraged thoughtful comparison rather than certainty. Such possibilities deserve careful handling. Oral traditions are not fossil catalogs, and they were never intended to function as scientific records. Their purpose reaches far beyond preserving descriptions of animals. They encode law, identity, relationships, geography, spirituality, and the responsibilities people hold toward country. Even so, Oral traditions can preserve observations with remarkable durability. Around the world, researchers have identified stories that appear to remember coastlines flooded after the last ice age or volcanic eruptions that occurred thousands of years before written history. Australia offers some of the oldest examples of this remarkable continuity. Conservative estimates place the continuous transmission of Aboriginal cultural knowledge at about 50,000 years, with some evidence suggesting even greater antiquity. That span reaches beyond agriculture, beyond cities, beyond every surviving written language. Countless generations inherited stories, refined them through careful retelling, and entrusted them to those who followed. Across that immense passage of time, memories of unusual animals may have become woven into narratives, carrying many layers of meaning at once, allowing fragments of lived experience to endure within living culture. Seen from that perspective, the disappearance of the megafauna did not erase them completely. Their bones entered the earth, while their possible reflections continued through spoken tradition, ceremony, and place. Whether every connection proposed by researchers proves correct or remains uncertain, the broader pattern reveals something extraordinary. The continent remembered. Its oldest stories carried impressions of a world once shared with giants, preserving a bridge between vanished ecosystems and the people whose ancestors first walked among them. Across an open stretch of Australian grassland, a red kangaroo pauses without warning. Its ears rotate toward the edge of nearby woodland. Every muscle becomes motionless, while its gaze remains fixed on a place where no movement can be seen. After several moments, it resumes feeding as though nothing had happened. Such pauses occur countless times each day, woven into ordinary life. They appear routine until the direction of that attention is examined more closely. Behavioral studies show that kangaroos are especially alert to danger approaching from woodland margins at roughly their own height. Aerial hunters inspire different responses, with eyes lifting toward the sky. Ground predators trigger another set of reactions altogether. This sideways vigilance, focused on an elevated approach through scattered trees, matches a hunting strategy that no longer exists on mainland Australia. Dingoes pursue prey across open ground. Birds of prey descend from above. Neither fits the pattern that continues to shape the instincts of these marsupials. The closest match belongs to Thylacoleo. Built for powerful ambushes from trees and woodland edges, it could launch toward prey from the side, striking with remarkable force before escape became possible. For millions of years, herbivores that detected such movement even a fraction earlier gained an advantage measured in survival and reproduction. Natural selection strengthened that awareness generation after generation until it became embedded within inherited behavior. Although the predator disappeared about 40,000 years ago, the response remains part of the kangaroo's ordinary life because evolution rarely erases successful adaptations with equal speed. The same pattern appears in anatomy as well as behavior. Wombats possess an unusually dense plate of bone fused across the rear of the body. When retreating into a burrow, a wombat can block the entrance with this reinforced shield, making it extremely difficult for a predator to pull it backward. Modern Australian predators seldom possess the size or power to justify such formidable protection. Earlier ecosystems, however, included enormous reptiles capable of inflicting tremendous biting force. A defensive structure that once increased survival continued passing from one generation to the next because it carried little disadvantage after the original threat vanished. Biologists describe these lingering traits as evolutionary hangovers, characteristics molded by selection pressures that disappeared long before the traits themselves. Evolution has no foresight and little urgency. When an adaptation remains useful or even merely harmless, it can persist across immense spans of time. Behaviors, body forms, and instincts become historical records written into living organisms instead of stone. Each surviving species carries traces of ecological relationships reaching far deeper than written history. Australia's surviving animals, therefore, inhabit two worlds at once. One is the present landscape, shared with predators that exist today. The other is an inherited landscape, preserved within instinct, where vanished hunters continue influencing decisions made every ordinary morning. A kangaroo still watches the woodland edge. A wombat still trusts the strength of its armored hindquarters. These actions are measurable features of biology, not poetic inventions. The giant predators disappeared, yet the selective pressures they imposed remain visible in the bodies and behavior of the creatures that endured, preserving one of evolution's longest lasting conversations between hunter and hunted. Ecologists sometimes begin with an unusual thought experiment. If a landscape remembers the roles once performed by vanished creatures, could another species step into part of that empty place? The question does not seek to recreate the past in perfect detail. It asks whether fragments of an ecological process can be restored after thousands of years of absence, allowing damaged systems to recover some of their former complexity. One of the strongest examples comes from another continent. When gray wolves returned to Yellowstone in the middle of the 1990s, the effects reached far beyond predator and prey. Elk changed where they spent their time feeding. Browsing pressure eased along riverbanks. Young willow and aspen recovered. Beavers expanded suitable habitat, and streams gradually shifted as vegetation stabilized their banks. Scientists describe this chain of connected effects as a trophic cascade, illustrating how one predator can influence an entire living network without directly touching every part of it. That success encouraged researchers to consider whether similar ideas could help Australia. The continent cannot recover Thylacoleo, Megalania, or the other vanished giants. Extinction has no reverse pathway. Even so, some scientists have explored whether ecological analogs, living species that perform broadly comparable functions, might restore portions of the interactions that disappeared. Large browsing animals could reshape vegetation. Powerful predators might regulate medium-sized and large herbivores. Other species could influence soils, water movement, and plant communities through their daily activity, rebuilding connections that have remained incomplete for many thousands of years. Among the most discussed possibilities is the Komodo dragon, the closest living relative of Megalania. Although it reaches only about 90 kilograms, which is about 198 pounds, far smaller than its prehistoric relative, it shares several important ecological traits. It hunts through ambush, consumes substantial carrion, and occupies the position of a dominant reptilian predator within its native environment. Those similarities have made it an intriguing subject in theoretical discussions, even though practical implementation remains highly controversial. The challenge extends beyond introducing another predator. Australia's surviving animals still carry behaviors shaped by encounters with species that disappeared long ago. Those inherited responses developed under hunting strategies unlike those of any living animal. A modern substitute would resemble the original only in broad outline. Prey might recognize certain signals while failing to recognize others, creating combinations of instinct and novelty that no previous generation experienced. Ecological restoration depends upon relationships developed across immense spans of time, and those relationships cannot be reconstructed with complete precision. Research repeatedly demonstrates another important pattern. Ecosystems lacking apex predators often become less diverse and less resilient. Herbivore numbers may rise beyond the capacity of vegetation to recover. Plant communities shift, altering food sources and shelter for countless smaller organisms. Each change spreads into another, reducing complexity across the landscape. The disappearance of dominant predators, therefore, represents more than the loss of individual species. It removes processes that once linked countless forms of life into a dynamic balance. Even the most ambitious rewilding effort could never rebuild exactly what Australia possessed before the megafauna vanished. More than 50 million years of isolated evolution produced relationships unique to that continent, shaped by pressures impossible to duplicate today. Science can restore fragments, strengthen damaged ecological connections, and improve resilience, yet some chapters remain permanently closed. The missing giants continue defining Australia's living world through their absence, reminding every generation that ecosystems are constructed over immense stretches of time. While their unraveling can unfold with astonishing speed, visitors often arrive in Australia carrying a familiar list of warnings. They learn about the inland taipan, the eastern brown snake, the box jellyfish, the Sydney funnel web spider, and the saltwater crocodile. None of these reputations emerged from exaggeration. Each animal possesses biological adaptations capable of causing fatal injuries under the right circumstances. The continent truly supports some of the most formidable venomous and aquatic predators alive today, and their presence has shaped how Australia is understood across the world. That reputation, however, reveals only the surviving edge of a much older story. The creatures that command attention in the present are largely compact, concealed, or equipped with chemical defenses. Venom, toxins, and microscopic stinging cells became the signatures of danger after another chapter had already ended. The immense hunters that once dominated the continent no longer stand within living memory, leaving behind a landscape where the greatest threats are measured differently than they once were. The saltwater crocodile remains Australia's largest surviving predator on land and in fresh water, although it also inhabits coastal environments. Mature males may reach 6 meters, which is about 20 feet, and possess the strength to overpower nearly any animal entering their territory. Even this impressive reptile represents only part of the ecological role once occupied by Quinkana. Fossil evidence suggests that land-dwelling crocodiles achieved similar lengths while carrying their bodies higher above the ground. Supported by limbs suited for pursuing prey across open country instead of wading almost entirely within the water. The same pattern appears across the broader predator community. No surviving mammalian hunter approaches the size or hunting influence once held by Thylacoleo. No living reptile matches the enormous scale attributed to Megalania. The largest flightless birds disappeared alongside the giant browsing marsupials they shared the landscape with. Australia still contains effective predators, yet the continent no longer possesses the towering collection of large-bodied hunters that directed ecological relationships for millions of years before their disappearance. Modern danger, therefore, depends upon concealment as much as size. A snake concealed within dry grass, a spider occupying a narrow crevice, or a jellyfish drifting through coastal water often remains unnoticed until the final moment. These hazards demand careful observation because they reveal themselves only briefly. During the late Pleistocene, the dominant threats occupied the opposite extreme. A giant reptile crossing open ground, a powerful marsupial predator descending from a branch, or a massive crocodilian advancing across dry land announced its presence through physical scale alone. The continent presented dangers that transformed entire landscapes through movement, appetite, and competition. This transition reflects more than changing appearances. It represents the long ecological consequences of losing the largest animals from every major habitat. As those giants vanished, food webs became less complex, predator roles contracted, and surviving species occupied a world with fewer large ecological engineers. Each disappearance narrowed the range of interactions, shaping vegetation, prey behavior, and nutrient movement across the continent. Australia remains one of Earth's most biologically distinctive places, filled with remarkable adaptations that continue to inspire research and respect. Even so, its celebrated reputation for danger is best understood as the surviving outline of something far larger. The venomous animals, formidable crocodiles, and resilient predators living today are enduring heirs to an ecosystem that once supported giants whose influence reached across every level of the living world, leaving traces that remain visible even after their bodies disappeared from the land. A child born in Australia today inherits a landscape that appears complete. Rivers continue their courses. Eucalyptus forests spread across rolling hills. Kangaroos gather on open plains, and birds fill the morning air with familiar calls. Each generation accepts the living world before it as the natural condition of the continent. Ecologists describe this gradual adjustment of expectation as a shifting baseline. Losses that occurred before living memory become invisible because no one remains to remember the world that came before them. The original baseline of Pleistocene Australia belonged to an ecosystem unlike any existing today. Enormous browsing marsupials cross the interior in seasonal movements, transporting nutrients across great distances. Multiple apex predators occupied separate hunting roles, dividing forests, open country, wetlands, and waterways into overlapping territories. Giant birds, reptiles, snakes, and mammals interacted through relationships refined across millions of years. The continent functioned as a complete network whose largest members shaped the lives of nearly every smaller species around them. When Diprotodon disappeared, far more vanished than a remarkable herbivore. Vast herds that once carried seeds, disturbed soil, and redistributed nutrients through their movements also disappeared. Their browsing influenced where shrubs expanded, where grasses recovered, and where young trees established themselves. Hooves and heavy bodies altered the surface of the land with each migration, creating countless opportunities for plants and smaller animals. As Australia's climate continued becoming drier through natural long-term change, those biological processes no longer operated with the same strength, leaving fewer natural forces capable of slowing the spread of increasingly arid landscapes. The disappearance of Thylacoleo removed another layer of ecological balance. It occupied a hunting position that no surviving Australian predator inherited. Medium-sized and large marsupials no longer faced attacks from a specialized ambush hunter capable of striking from elevated positions before pursuing prey across short distances. As predator pressure changed, feeding behavior shifted with it. Herbivores spent more time in places that once carried greater danger, gradually altering patterns of browsing and allowing vegetation communities to develop along different paths than they had for countless generations. The loss of Megalania erased another essential function. An enormous reptilian predator also served as a large-scale scavenger, consuming carcasses that otherwise remained across the landscape. Through feeding, decomposition accelerated, nutrients returned to soils, and disease-carrying remains disappeared more rapidly. No surviving Australian reptile approaches the body size necessary to perform those tasks across comparable areas. The ecological work once carried out by a single giant species fragmented into smaller processes that never fully replaced its influence. This absence is difficult to perceive because it produces no immediate spectacle. The silence left behind does not arise from empty forests or lifeless plains. Birds still sing, insects continue their endless activity, and surviving mammals remain busy with ordinary lives. The missing element exists within ecological function itself. Certain interactions no longer occur because no living species possesses the anatomy, body mass, behavior, or evolutionary history required to perform them. A complete ecological vocabulary lost many of its defining words. Modern Australia, therefore, represents both extraordinary resilience and enduring absence. Its ecosystems remain rich, distinctive, and biologically remarkable, yet they continue operating without several of the largest architects that once sustained them. Their disappearance reshaped relationships extending from predators to plants, from soils to waterways, leaving behind a continent whose living beauty still carries the outline of an older design that can never be fully reconstructed. Every ecosystem is built upon relationships rather than individual species. A forest does not endure because trees stand together, nor does a grassland thrive because herbivores graze across it. Each living community depends upon countless interactions, many of them directed by the animals occupying the highest places in the food web. Modern ecology increasingly recognizes that apex predators are not decorative additions to nature. They organize the entire system, preserving the balance that allows complexity to emerge and persist across generations. When such a predator disappears, the first change seems straightforward. Fewer hunters mean greater safety for prey. Yet the deeper consequences unfold through thousands of ordinary moments repeated over immense spans of time. Every pause before entering open ground, every glance toward a tree line, every decision to remain close to a herd or move away from it developed under constant selection. Survival depended upon making the correct choice, often enough to leave descendants, remove the predator, and those pressures begin to fade from daily life. The prey animal itself gradually changes in response. Traits once essential become less valuable when they no longer influence survival or reproduction. Exceptional vigilance carries energetic costs. Powerful escape abilities demand resources that might otherwise support growth or breeding. Social coordination developed under persistent danger may weaken when coordinated defense becomes less necessary. Evolution does not preserve complexity for its own sake. It preserves only those characteristics that continue contributing to successful reproduction within the conditions of the present environment. Thylacoleo shaped those conditions for an immense stretch of Australian history. Every successful ambush removed individuals that reacted too slowly or chose poorly under pressure. Animals that detected danger earlier remained attentive to companions or escaped with greater efficiency passed those qualities to future generations. Across roughly 2 million years, this continual filtering influenced countless populations of browsing marsupials. The predator did far more than consume prey. It participated in determining which inherited characteristics remained common throughout the landscape. That principle extended beyond a single hunting relationship. Megalania influenced scavengers through competition for carrion. Quinkana affected the behavior of animals approaching rivers and wetlands. Large herbivores transformed vegetation, altering where predators hunted and where smaller creatures found shelter. Every interaction strengthened another somewhere else in the network. Complexity emerged because each participant continually responded to the presence of every other participant, creating a living system whose richness exceeded the contribution of any single species. Seen from that perspective, the great predators were never obstacles standing in the way of a flourishing ecosystem. They were among its principal architects. Their presence sustained productive tension across the landscape, encouraging diversity in behavior, anatomy, movement, and ecological function. Without that tension, food webs gradually simplified, interactions narrowed, and evolutionary pathways became less varied than they had once been. Remembering Australia's lost megafauna therefore means recognizing more than remarkable creatures with extraordinary bodies. It means acknowledging the disappearance of an entire level of biological organization that required about 50 million years of isolated evolution to assemble. The collapse unfolded within less than 2,000 years, a brief interval compared with the immense history that preceded it. The surviving continent remains extraordinary, yet it carries the outline of a richer design whose full complexity can now be approached only through fossils, ecological evidence, and the enduring patterns left behind in the living world that followed. The story carried across this continent does not end at its shoreline. Its outline appears again and again across the world, woven into the closing chapters of the late Quaternary extinction event. As modern humans spread from Africa into new lands, many regions experienced the disappearance of their largest animals. Mammoths vanished from northern landscapes. Giant ground sloths disappeared from the Americas. Enormous flightless birds faded from islands, and other great herbivores and predators slipped into history. Australia formed one chapter within that wider transformation, though its chapter followed a path unlike any other. Its distinction lies in the scale of what vanished. No other continent lost such a large proportion of its great terrestrial animals within such a relatively brief interval. Isolation had shaped Australian life for roughly 50 million years, producing predators, herbivores, and ecological relationships found nowhere else. Those animals evolved without encountering a tool, using species capable of altering vegetation, moving across every habitat, and adapting to almost any source of food. Their evolutionary experience offered little preparation for that entirely new influence. Many researchers, therefore, regard Australia as one of the clearest demonstrations of how biological originality can become vulnerability. A system refined through immense spans of time proved remarkably successful against droughts, shifting climates, and internal ecological change. It proved far less resilient when confronted with pressures outside the range of anything it had previously experienced. The continent retained much of its uniqueness, yet the disappearance of its giants permanently altered the direction of its ecological history. That history carries unusual relevance because another global decline is unfolding today. Ecologists often describe the present era as the sixth mass extinction, reflecting biodiversity losses occurring at rates far above the natural background level recorded through much of geological history. Habitat destruction, climate change, invasive species, pollution, and direct exploitation combine to reduce populations across almost every major ecosystem. The causes differ from those operating during the late Pleistocene, yet familiar patterns emerge within the statistics. Large animals remain especially vulnerable because they mature slowly, produce relatively few offspring, and require extensive habitats that become increasingly fragmented. As their numbers diminish, the ecological work they once performed also fades. Seed dispersal weakens, predator regulation declines, nutrient movement becomes less efficient. Every disappearance removes another thread from the larger fabric, leaving the remaining structure less intricate than before. Australia now occupies an unusual position within that continuing story. The continent experienced one profound ecological transformation roughly 40,000 years ago, and today many surviving native species face another period of sustained decline. Quolls have disappeared from much of their former range. Numbats survive in scattered populations. Bilbies occupy only fragments of their earlier distribution. Tasmanian devils persist naturally only on the island that gave them their name. Southern cassowaries continue within shrinking rainforest habitats where each remaining population becomes increasingly isolated. This second wave unfolds with far less spectacle than the first. There are no towering reptiles crossing open plains or immense browsing marsupials fading from the horizon. Instead, populations contract year after year, often measured first in surveys, maps, and field reports before becoming visible in everyday experience. Such gradual change easily becomes accepted as ordinary, even while the living world grows incrementally less diverse. Australia therefore stands as both a record of an ancient ecological turning point and a reminder that the processes reshaping nature have never belonged entirely to the distant past. Some stories become clearer as new discoveries accumulate. This one has followed a different path. Each excavation, improved dating method, and renewed examination has sharpened certain details while softening others. After decades of investigation, the disappearance of Australia's great animals remains one of the most carefully studied mysteries in natural history. As the evidence has grown, certainty has not always grown with it. The scientific conversation has shifted repeatedly across the years, and by the middle of the 2020 decade, the balance had changed again. Researchers openly acknowledged that the debate surrounding the extinction of the Australian megafauna had become less settled than it appeared a decade earlier. The overturning of a long accepted piece of hunting evidence reminded scientists that even widely accepted conclusions remain subject to revision when stronger analysis becomes available. The role of humans, therefore, remains under active examination, neither dismissed nor conclusively demonstrated beyond doubt. Part of that uncertainty comes from the evidence itself. The fossil record of Pleistocene Australia is remarkably incomplete across such an immense continent. Fewer than 200 fossil localities preserve remains from the critical interval surrounding the extinctions, and only a relatively small proportion have been dated with high confidence. Many regions preserve almost nothing at all. Others contain isolated fragments separated by immense distances and spans of time. The pattern resembles a book with most of its pages missing, leaving scattered paragraphs that must somehow reveal the complete narrative. This limitation does not reflect weak science. It reflects the immense passage of roughly 50,000 years and the realities of preservation across Australian landscapes. Bones decay, sediments erode, rivers shift course, and ancient surfaces disappear beneath younger deposits. Countless animals lived and died without leaving traces that survived into the present. Every fossil recovered today, therefore, represents an extraordinary survivor from a record that has largely vanished. Each new discovery improves the picture, yet large spaces remain between the surviving pieces. An honest scientific conclusion accepts those spaces instead of pretending they do not exist. Humans may have played the decisive role in one of the greatest biological losses ever experienced by a continent. Climate may have weakened ecosystems before people arrived. Fire management may have reshaped vegetation in ways that amplified existing stresses. Several influences may have acted together, each contributing part of the final outcome. Present evidence supports aspects of each possibility while leaving important questions unresolved. There is unusual value in that uncertainty. It resists the temptation to transform history into a simple moral lesson with a single cause and an unmistakable conclusion. Reality often preserves sharper edges than stories do. An extraordinary ecosystem encountered an adaptable species entering unfamiliar landscapes. Across thousands of years, those lives became intertwined in ways that remain only partly visible through the surviving evidence. The consequences were unmistakable, even while the precise sequence of causes continues to invite careful examination. The question therefore remains alive, carried forward by every fossil, every improved dating technique, and every new field season across Australia's immense interior. Complete certainty may never arrive. Even so, the continued search possesses its own importance. It reflects a willingness to examine the past with patience, to revise conclusions when stronger evidence appears, and to accept that some of nature's greatest transformations can remain partly beyond recovery, even while their consequences continue to shape the living world. Some archives are built from paper, while others wait inside limestone. Across southern Australia, entire chapters of vanished life remained untouched until chance, patience, and careful exploration brought them back into daylight. The continent has preserved fragments of its oldest story in places where time itself became the keeper, protecting bones long after every living witness had disappeared. Among the greatest of these places are the Naracoorte Caves in South Australia. Within their chambers lie the remains of marsupial lions, giant browsing marsupials, towering short-faced kangaroos, and immense constricting snakes. Many reached those caverns through openings in the cave roof, falling into spaces from which escape was impossible. Their bodies settled layer upon layer, gradually covered by sediments that shielded them from weather, scavengers, and countless centuries of change. Long after their landscapes transformed beyond recognition, the caves continued preserving a remarkably detailed record of the community that once lived above them. Those underground collections continue to reshape scientific understanding until the early years of the 21st century. No complete skeleton of the marsupial lion had ever been recovered. Scientists understood the predator from scattered bones gathered over many decades, carefully reconstructing its appearance from incomplete evidence. Then, during the month of May in the year 2002, cave explorers searching a remote part of the Nullarbor Plain located previously unknown cave entrances after spotting subtle openings from an ultra-light aircraft. Inside those chambers rested exceptionally complete skeletons of marsupial lions, preserved across tens of thousands of years with astonishing completeness. The discovery transformed far more than museum displays. Entire aspects of anatomy, movement, and posture could suddenly be examined directly instead of inferred from isolated fragments. Questions that had remained open for generations acquired clearer answers, while entirely new questions emerged from details no researcher had previously been able to observe. A single unexpected discovery demonstrated how incomplete the fossil record still remained and how rapidly understanding could change when another hidden chamber entered scientific study. That process continues today. Every newly dated specimen refines extinction chronologies. Every cave system explored contributes additional evidence about diets, habitats, behavior, and relationships among species. Scientific knowledge of Pleistocene Australia has changed substantially from the beginning of the 21st century to the present, and there is every reason to expect further revision as additional discoveries emerge. The record is not finished. It continues expanding with each carefully documented excavation. Another record has continued as well, carried not through stone but through generations of storytelling. Aboriginal Dreamtime traditions have preserved narratives associated with remarkable animals, distinctive landscapes, and enduring places of water across spans unmatched by any written civilization. These traditions remain living cultural knowledge, transmitted continuously across immense stretches of time. Scholars increasingly recognize that they deserve careful attention alongside archaeological and paleontological evidence, while respecting their cultural significance and independent value. One record is written in calcium, sediment, and mineral deposits. The other is carried through memory, language, and repeated telling. They arise from different ways of preserving knowledge, yet they sometimes point toward the same vanished creatures, familiar waterholes, and enduring landscapes. Neither replaces the other. Together, they offer complementary windows into a continent whose oldest history still unfolds piece by piece. Australia continues revealing that forgotten world, not as a completed account resting on a shelf, but as an ongoing conversation between deep time and the present, where every new discovery broadens the story without ever fully exhausting it. A single animal can capture attention, yet the deeper story only appears when every remarkable creature is viewed together. The landscape they shared stretched across a continent nearly as large as the contiguous United States, shaped through about 50 million years of geographic isolation. During that immense span, evolution worked with a collection of marsupials, reptiles, and birds found nowhere else, producing solutions unlike those that emerged on any other landmass. Australia became an independent biological workshop, refining life along pathways that remained separated from the rest of the world for longer than human imagination comfortably grasps. The results still challenge expectation. One lineage of plant-eating ancestors eventually gave rise to the marsupial lion, whose jaws generated the strongest bite force relative to body size ever measured in a mammal. Another branch produced the largest terrestrial lizard presently known from the fossil record, an immense predator widely considered to have possessed venom, making it the largest venomous animal yet recognized in the history of life. Crocodilians developed forms that spent their lives pursuing prey across dry ground, their limbs built for movement over land instead of long hours floating in rivers. Giant browsing marsupials reached the size of rhinoceroses, traveling across broad regions in substantial herds, while enormous flightless birds descended from waterfowl grew to weights approaching half a ton. None of these creatures represented copies of animals living elsewhere. Their closest ecological equivalents often belonged to completely different branches of the evolutionary tree. Similar roles emerged through different bodies, different histories, and different anatomical possibilities. Australia repeatedly arrived at answers that no other continent produced. Each species carried the signature of prolonged isolation, shaped by environmental pressures acting within a world largely disconnected from outside influence. Considering any one of these animals alone already stretches the imagination. Seen together, their community becomes even more remarkable. The marsupial lion was not the singular ruler of its landscape. It shared that role with several other formidable predators occupying different hunting strategies and habitats. Giant reptiles, terrestrial crocodilians, massive snakes, and specialized mammalian hunters formed overlapping layers of predation. Herbivores responded with equally diverse adaptations, creating an intricate network of movement, vigilance, migration, and survival that unfolded across immense distances. Such richness emerged through uninterrupted evolutionary time measured in millions upon millions of years. Generation followed generation, each contributing minute changes that accumulated into entirely original ecosystems. No engineer designed that complexity. No guiding intelligence selected those outcomes. Countless interactions among climate, geography, competition, chance, and natural selection gradually assembled one of the most distinctive vertebrate communities ever known. Researchers studying these fossils continue encountering discoveries that overturn earlier assumptions. Newly recovered skeletons reveal unexpected anatomy. Fresh dating methods alter extinction timelines. Previously unexplored cave systems expose species associations no one anticipated. Even after generations of investigation, Pleistocene Australia remains capable of surprising the scientists most familiar with its history. A reminder that remarkable evolutionary outcomes often exceed predictions formed from living ecosystems alone. Viewed from this wider perspective, the continent stands as one of nature's grandest demonstrations of evolutionary possibility. For about 50 million years, life explored an extraordinary collection of biological paths, producing creatures found nowhere before or since. That immense experiment reached its conclusion roughly 40,000 years ago. What endures today is its enduring record, preserved within stone, carried through story, and reflected in the living descendants whose bodies and behaviors still bear traces of that vanished world. Deep time resists ordinary thought, a calendar, a lifetime. Even the rise and fall of civilizations become almost weightless beside spans measured in millions of years. Looking across Australia through that wider lens changes every familiar scale. The continent drifting into prolonged isolation, the appearance of remarkable animals, their flourishing, and their disappearance all belong to one continuous story, unfolding across an interval so immense that the human mind can only approach it through comparison. About 50 million years ago, Australia separated from the last major connections to other southern lands and continued its long movement northward. During those millions of years, climates shifted, coastlines transformed, forests expanded and retreated, and open country spread across the interior. Every generation inherited a landscape slightly altered from the one before. Countless lives unfolded within those gradual changes. Every birth, every hunt, every migration, every season of abundance, and every extinction became another thread woven into a tapestry that stretched almost beyond measure. Modern humanity occupies only a tiny portion of that timeline. Homo sapiens has existed for roughly 300,000 years. Agriculture, permanent settlements, written language, and recorded history together reach back only about 10,000 years. Australia's evolutionary isolation therefore lasted around 5,000 times longer than the span covered by written human memory. Entire civilizations appear and disappear almost instantly when placed against that background, while evolutionary change continues at its own measured rhythm. Within that extraordinary duration, marsupials diversified into nearly every major ecological role available on land. Small insect hunters explored the undergrowth. Browsers and grazers expanded into immense herbivores. Specialized predators refined bodies suited for climbing, pursuit, or ambush. Reptiles descending from ancestors that once shared the supercontinent of Gondwana also continued changing, eventually reaching sizes that still surprise paleontologists. Each lineage responded to countless interactions with climate, food, competition, disease, and one another, creating relationships refined across millions upon millions of years. The epoch, known as the Pleistocene, began about 2,600,000 years ago and ended approximately 11,700 years before the present. During much of that interval, Australia's giant animals reached their greatest diversity and ecological influence. The marsupial lion remained among the continent's dominant predators for roughly 2 million years, a tenure extending far beyond the entire existence of Homo sapiens. Generations beyond counting inherited instincts shaped by predecessors, stretching into a distant past almost impossible to picture. When the final marsupial lion disappeared, an evolutionary pathway refined across those 2 million years came to its conclusion. The last Diprotodon marked the end of giant browsing marsupials, whose lineage had endured for about 1,770,000 years. The disappearance of Megalania closed another chapter, rooted in giant monitor lizards whose ancestry reached far deeper, tracing back through Australia's connection with Gondwana. Each extinction represented more than the loss of a species. It concluded an unbroken sequence of adaptation that had survived immense stretches of geological time. Seen from this perspective, these creatures were never brief experiments. They belonged to lineages tested across ages beyond ordinary comprehension, refined through persistence instead of haste. Their disappearance compressed into a comparatively brief moment what evolution had assembled across millions of years. Deep time offers no simple consolation. It reveals the extraordinary patience with which life creates originality, and how swiftly an irreplaceable chapter can pass from the living world into memory preserved only through fossils, landscapes, and enduring traces carried across the present. Some losses leave traces that invite repair. A burned woodland may green again after seasons of rain. Rivers can clear, populations can expand, and damaged habitats sometimes regain much of what they once supported. Extinction belongs to a different category altogether. It marks a boundary beyond which recovery no longer exists. Once the final member of a species dies, an entire evolutionary story reaches an ending that no future generation can reopen. The marsupial lion illustrates that finality with unusual clarity. About 2 million years of evolutionary refinement shaped its remarkable anatomy. Powerful jaws achieved the greatest bite force relative to body size known among mammals. Retractable claws formed an exceptional hunting toolkit. Muscles, senses, instincts, and behavior evolved together through countless generations until they became perfectly suited to their ecological role. When the last individual disappeared, every inherited adaptation vanished alongside it. The genetic information that produced those traits, the learned behaviors passed between generations, and the ecological influence they exerted across the landscape all became permanently inaccessible. No scientific advance changes that reality. Conservation programs can protect species that remain alive. Habitat restoration can strengthen struggling ecosystems. Rewilding may recover certain ecological processes through carefully chosen living substitutes. None of these approaches can recreate what prolonged isolation accomplished across about 50 million years. That achievement depended upon one continent following its own path through changing climates, shifting landscapes, evolving predators, adapting prey, and millions upon millions of years of uninterrupted natural selection. Alter any part of that sequence, and evolution produces something different. For that reason, prehistoric life represents more than a collection of remarkable fossils. It preserves evidence of biological possibilities that once existed and now belong entirely to history. Every extinct lineage expanded the range of forms that vertebrate life could achieve. Their disappearance narrowed that range forever. The fossil record therefore documents both extraordinary creativity and permanent reduction, recording not only what evolution accomplished, but also what it can no longer revisit through the same pathway. The disappearance of the marsupial lion reduced the diversity of mammals in a literal sense. No living predator occupies its exact position within mammalian evolution. No surviving lineage combines its ancestry, anatomy, and ecological function. The world did not merely lose another carnivore, it lost one distinct expression of what mammalian evolution was capable of producing. Similar observations apply to the giant browsing marsupials, the immense monitor lizards, and the terrestrial crocodilians that once shared this continent. Each represented an outcome that will never appear again through the same evolutionary journey. Another perspective deepens that realization. These disappearances occurred roughly 40,000 years ago, long before cities, agriculture, writing, or recorded history emerged. Every kingdom, every empire, every scientific discovery, and every generation remembered through written records unfolded after those animals had already vanished. Humanity inherited a continent whose greatest biological experiment had already been profoundly diminished. The landscapes explored by later cultures were landscapes shaped by absence as much as presence. Modern Australia, therefore, carries two histories at once. One lives within the thriving species that continue adapting to changing conditions. The other survives through fossils, enduring traditions, and scientific reconstruction, preserving the outline of an irreplaceable world. Irreversibility gives that vanished world its enduring significance. It reminds us that evolution creates originality through immense patience, while extinction closes possibilities with a permanence unmatched by any other change known in the living world. At the edge of an open clearing, a kangaroo pauses without any visible signal, demanding caution. Each ear turns on its own, collecting sounds from different directions. Powerful hind legs settle into a balanced stance, ready to launch sideways through scattered trees with astonishing speed. The surrounding landscape appears ordinary, yet the posture belongs to a far older conversation. Long ago, predators hidden among trunks and branches rewarded hesitation with death. The hunters disappeared, while the response remained, carried from one generation to the next through instincts that still shape movement across the continent. A wombat offers another reminder. As danger approaches, it withdraws into its burrow until only the broad rear of its body blocks the entrance. Thick bone reinforces that shield, forming protection capable of resisting crushing force and delivering powerful backward pressure against anything attempting to enter. No living Australian predator regularly challenges that defense with the strength once possessed by the largest hunters of the continent. Even so, natural selection has not erased the structure. Evolution rarely abandons an effective design unless maintaining it becomes costly, and this remarkable safeguard continues to travel through time with the species that inherited it. Along northern rivers, the saltwater crocodile waits with patient precision, almost unchanged in its fundamental body plan across roughly 200 million years. It remains Australia's largest living apex predator and commands respect wherever fresh water meets the sea. Even this formidable reptile represents only part of an earlier community. Its predecessors included terrestrial crocodilians, adapted for pursuing prey across open ground, giant monitor lizards occupying the highest levels of the food web, and the marsupial lion, whose climbing ability expanded the landscape of danger into trees as well as across the earth beneath them. The surviving crocodile preserves one branch of that wider predatory heritage, while many others exist only through fossils. Viewed together, these examples form a continuous narrative instead of isolated observations. Living animals preserve behaviors shaped by vanished relationships. body structures developed through contests that no longer occur. Ecological roles have contracted, while inherited responses continue moving through populations that no longer encounter the full range of pressures responsible for creating them. The continent still carries evidence of its earlier complexity, expressed through anatomy, instinct, and patterns of movement that outlived the conditions that first favored them. That continuity reaches back about 50 million years, when Australia separated from Antarctica and followed its own evolutionary path. Isolation granted mammals, reptiles, and birds an opportunity to diversify without competition from many familiar groups found elsewhere. Over immense spans of time, natural selection explored possibilities unlike those produced on any other landmass. Predators refined specialized hunting strategies. Herbivores transformed landscapes through feeding and migration, and every interaction contributed another layer to an ecological system of extraordinary originality. The Great Experiment eventually reached an irreversible turning point. Its most distinctive giants disappeared, while many smaller descendants endured. Those survivors became living archives, carrying fragments of a vanished world within their bones, reflexes, and inherited behavior. A startled leap, a fortified burrow entrance, or the patient watchfulness of a crocodile reflects influences extending far beyond the present day. The monsters shaped Australia across millions of years, and although they no longer walk the continent, the living creatures that remain continue bearing their enduring imprint through every generation that follows. Far from roads and cities, where limestone chambers remain sealed beneath the Nullarbor plain, the outline of a marsupial lion still rests where chance preserved it. The complete skeleton discovered in 2002 did not conclude a scientific search. It began another one. Each careful examination has revealed details that earlier generations could not recognize, from the strength of its climbing limbs to the structure of its paws, the wear on its teeth, and the marks left by a predator that sometimes used caves as shelter. An animal that drew its final breath roughly 40,000 years ago continues shaping research through evidence that had waited patiently within stone. Elsewhere, the chambers of Naracoorte preserve another gathering from that vanished continent. Diprotodon, Procoptodon, Wonambi, and Genyornis remain where accidents carried them into deep cave systems from which there was no return. Their bones endured because darkness, stable conditions, and the absence of scavengers protected them across immense spans of time. Together they record a community unlike any now living. Every skeleton contributes another page to a story assembled from separate discoveries, allowing paleontologists to compare anatomy, estimate movement, reconstruct diets, and recognize relationships that would otherwise remain invisible. The record extends beyond fossils alone. Across Australia, oral traditions maintained by Aboriginal peoples describe immense serpents dwelling within waterholes and giant wombat-like creatures moving across the landscape. These traditions belong to the oldest continuous cultural heritage on Earth and have traveled through countless generations by spoken memory. Researchers continue exploring places where descriptions within those traditions align with paleontological discoveries, geographic features, and long-remembered ecological patterns. Each source preserves knowledge in its own way, one through mineralized bone and the other through living narrative, offering complementary paths toward understanding landscapes transformed by time. Scientific knowledge remains unfinished because the evidence itself continues expanding. New cave systems are documented. Previously collected fossils receive more precise dating through improved laboratory techniques. Chemical analysis uncovers information once thought permanently inaccessible, including dietary clues and environmental conditions surrounding extinction. Small adjustments to chronology sometimes reshape larger interpretations, revealing that a single specimen can alter discussions extending across an entire continent. What seemed settled a generation ago may become uncertain again after one carefully dated discovery emerges from beneath sediment or limestone. This continuing process gives paleontology an unusual character. The past does not remain fixed behind a closed door. It arrives piece by piece, carried upward from caves, dry lake beds, riverbanks, and exposed cliffs. Every fossil enters the present with information unavailable before its discovery. Researchers ask new questions because fresh evidence makes them possible, and older conclusions become stronger, weaker, or entirely different through comparison with material that had never been examined. The marsupial lion still contributes to discussions about how it captured prey. Giant monitor lizards continue refining estimates of their true size and ecological role. Terrestrial crocodilians reveal new clues about locomotion and hunting as additional specimens come to light. None of these animals can return, yet each discovery enlarges their presence within human understanding. Across Australia, stone continues, yielding fragments of a forgotten world, while enduring traditions preserve memories that traveled beside it. Together, they remind us that even after 40,000 years, the continent has not finished telling its story. Night settles across Australia once again. Above the deserts, forests, rivers, and grasslands, the Southern Cross returns to its familiar place, while the pale band of the Milky Way stretches across the sky, much as it did tens of thousands of years ago. Those same stars once shone over marsupial lions moving through woodland canopies, over Diprotodon herds following seasonal pathways across the interior, and over predators and prey whose lives unfolded long before the first city, the first written language, or the first monument of human civilization. Across an open plain, a kangaroo pauses before taking another bound. Its ears turn independently toward the surrounding woodland, gathering every sound carried by the evening air. Nearby, a wombat disappears into a burrow, trusting the reinforced shield of its hindquarters to guard the entrance if danger arrives. Farther north, a saltwater crocodile waits with patient certainty beside the water, occupying a landscape that once supported terrestrial crocodilians whose descendants no longer exist. Each survivor continues living within an environment shaped by relationships that vanished long ago, preserving responses inherited from a world that has otherwise slipped beyond reach. The continent itself still bears the outline of that older system. Rivers continue following valleys carved across deep time. Ancient soils support communities of plants that evolved alongside giants now absent. Ecologically, the landscape functions with fewer participants than it once held. Migrations that redistributed nutrients across enormous distances have ended. Predators occupying specialized hunting roles no longer influence the behavior and evolution of their prey. Many interactions that once connected every level of the food web survive only through their lingering effects upon the species that remained. Even so, absence does not erase memory. It settles into the land in different forms. Fossils preserved within limestone continue revealing details of vanished anatomy and behavior. Oral traditions carried across countless generations preserve accounts connected to places where extraordinary animals once lived. Scientific debate continues refining dates, ecological relationships, and extinction scenarios as each discovery adds another fragment to a story that remains incomplete. The continent has never stopped offering evidence to those willing to study it with patience and care. Imagining Australia with its megafauna still present captures only part of what has been lost. Those animals were not larger versions of familiar creatures. They belonged to an evolutionary experiment unlike any other, produced through roughly 50 million years of geographic isolation and continuous adaptation. Their interactions generated ecological patterns that have no complete equivalent anywhere on Earth today. The continent did not merely contain remarkable species, it sustained an entire biological world, assembled through millions upon millions of years of uninterrupted change. That world disappeared, yet its influence continues through every surviving descendant, every preserved skeleton, every enduring tradition, and every new scientific discovery emerging from stone. The monsters shaped the continent that exists today. They molded the instincts carried by living animals, the structure of ancient ecosystems, and the stories remembered across human generations. Their world can no longer return, but its presence remains woven through rock, reflex, landscape, and memory. Under tonight's familiar stars, Australia continues carrying the imprint of the extraordinary life that once transformed it into one of evolution's most original creations.